everyone, my name is Melissa Kim, and I'm super excited to be here to talk to you today about fire retardants and how they've evolved over the years to meet the challenges of wildfire season. I'm going to start off with a brief background of myself and Perimeter Solutions. I'm the Vice President of R&D for Perimeter Solutions. I've been developing fire safety products for almost 20 years. I started right out of college, got bit by the fire bug, and I've been doing this ever since. I've had this great passion that's developed over the years. My team is responsible for product development worldwide. And Perimeter Solutions actually produces a number of different brands, including Phosphate, Solberg, FireTrol, and Xchemia fire safety products that encompass fire retardants, Class A foam, and Class B foams. We have 60 years of industry experience. We're sold internationally, and we just recently celebrated our 1-year anniversary as listed on the New York Stock Exchange. So I'm going to start by what is the issue at hand. Fire seasons are getting longer and they're getting more intense. So much so that over the last couple of years, I've actually heard there's not really a fire season, but actually the fire season is a fire year. There's a couple of things contributing to that. And one of those things you can see in the bottom pictures of the United States is the average temperature has increased significantly to the point where almost the entire United States is red, which means we are above average when it comes to temperature. That is contributing to these longer fire seasons as the forest health is declining, the temperatures and the droughts increasing, and the growth of the wildland urban interface, or the WUI, is increasing as well. And the graph on the right shows the average fire size, and you can see that over the last 30, 40 years that it has steadily increased over that time. So much so, all of these things are affecting human health. And in 2021, carbon dioxide emissions totaled almost 2 billion metric tons globally. And the smoke from these fires kill around 33,000 people around the world each year. And this isn't just a North American or United States issue. It really is a worldwide crisis. When I started 20 years ago, I really didn't hear too much internationally. It was North America, Australia, Europe. But as you can see here, the percent change in high risk fire days per year in all these areas has increased almost 100%. So let's talk about phosphate-based fire retardants. This is really what gets me excited. This is really our basis. Phosphate fire retardants have been studied and researched for more than 80 years. And there's 3 really big significant studies that occurred during that time, the early years. And one of them was the 1940 study conducted by the University of Idaho. And what that study showed was that they studied different chemicals. What can we use to really help fight these fires? And so what they found is diammonium phosphate and monoammonium phosphate were in the top 3 in that list. And the chlorides, the ammonium chlorides and the magnesium chlorides, were on the bottom. So what this showed was that diammonium phosphates and monoammonium phosphates were one of the most effective chemicals to use in fire retardants. And then in 1954 and 1970, the Operation Fire Stop and the Blakely Report, they repeated some of these studies, tested a couple of different things, fire intensity versus, combustibility. And what it showed was ammonium phosphates, again, were the most effective. So how do these phosphate retardants work? So again, this is what gets me excited. Phosphate fire retardants work chemically by altering the way that cellulose decomposes. So it actually renders the fuel non-flammable, where untreated fuel or cellulose decomposes into flammable gases, which actually continue to burn and accelerates it. The treated cellulose actually dehydrates into carbon and water, and the carbon is that black char you see, and the water you can see coming off as vapor. Phosphates are the only chemical that actually do this. Other chemicals may retard a fire, but it will continue to burn until there's nothing left but ash. And so phosphates is really the only chemical that actually dehydrates into carbon and water. And it's effective when dry. Water is only used to get the chemical to the ground and cover, the fuel that's on the ground. And it remains effective until it's removed by heavy rain. So I'm going to show you a video here to show you actually how it works. And what you'll see is the top 2 pictures, pretty pink, that's our MVPFX and LCU20FX fire retardants. And the bottom bed is an untreated control. And as you see the video go through, you'll see how that phosphate works to show that char and that water vapor. And you'll see a second video that actually shows our uncolored prevention and protection products. And whether it's colored or not, it performs the same. The chemical is still there. And you'll also see where that stops the fire, it runs into the treated material and stops and turns into a char. So right there, the material on the left is untreated. The fire burns through that, gets to the retardant line and actually stops it, where the bottom one completely burns through and totally consumes the fuel to ash. Here's our ground applied unit. And again, untreated, just because the color is not there does not mean it doesn't work. This is our fortified LCE20W. Same reaction, same chemical reaction. All that smoke you see is actually that water vapor coming off, cooling the fire. So now I'm going to get into the evolution of fire retardant technology. In 1963 was really the first phosphate-based product commercialized, and the first commercialized gum thickened retardant. And this was important because phosphate was a chemical that put the fire out, but you had to get the chemical on the fuel. So the gum actually helped facilitate that. Coming out of aircraft, high rate of speed, you want to keep that retardant cloud together and get that recovery on the ground, and the gum helped facilitate that. So it actually made the product more effective because the recovery rate on the ground significantly increased with the gum. In 1971 was the first retardant approved for fixed tank helicopters. This was really important too because magnesium is a component of fixed tank helicopters. We wanted to make sure that that product was safe and that it was going to meet those corrosion requirements so that that tool could be used. This introduced another tool to the toolbox and another vessel to lay fire retardant down. And there was also the year that it was the first colored fire retardant. Traditionally, during that time, it was a red iron oxide color, that dark red, very visible color, also very staining, which gets us into 1975 with the introduction of fugitive colored retardant. It was developed because there was a fire in a national park, and they refused to use fire retardant because they said they'd rather have a black forest than a red forest. And so at that time, it was kind of a shame that there was this tool, but it wasn't being used just based on its color. So fugitive color was developed, and there was a product developed using the fugitive color that actually, once you laid it on the ground, you could see it, and over the course of 2 or 3, 4 months, it would fade with UV light. And the visibility of this is important, right? You're having pilots in smoking conditions, not very visible. They need to see where that line has been drawn, where the retardant has been laid, so that way when they come back around with the next load, they can tie into that first line and really reduce the gap and prevent fire from going through that gap. In 1985 was the sulfate ammonium phosphate blends were introduced, and then 2004 was the gum thickened liquid concentrates. Previous to this, it had been traditionally powdered products with the gum, but in 2004 some technology was developed that was introduced with the liquid concentrate. So in 2013, we built a new state-of-the-art facility in Southern California in Rancho Cucamonga. This allowed for more efficient and higher volume production to get to our customers quicker. In 2014, high visibility fugitive color was introduced. This was a replacement to the previous fugitive color, which was a fine color. However, there had been reports that it wasn't as visible as the iron oxide, and so the iron oxide had always been that standard. And there was the fugitive was a little bit more difficult to see on the ground, and so a project was put into place to develop a higher, more visible fugitive product. And so to this day, it's our current magenta, beautiful color that comes out of aircraft, and it's actually, there's reports in some situations that it's actually more visible than the iron oxide was. In 2019, we acquired River City Fabrication. That allowed us to internally service our customers with any kind of equipment and tanks and any needs on the equipment side of things. And in 2020, we developed LCE20FX, which was a new liquid concentrate with superior performance and a lower environmental footprint. And then in 2021, our ground applied line of fire retardants for pretreatment, prevention, and protection was launched. So where do we go from here? Look ahead. The wildfire threat is increasing. It's not going to go away. We've seen the graphs, the increase over the last 30, 40 years. Climate change, the drought, the WUI expansion is just leading to more dangerous situations in wildfire seasons. In fact, the UN predicts global wildfires to increase by 14% in 2030, which is 7 years away, and by as much as 50% in 2100. And so what do we need to do? What is the industry response to that? There needs to be a transition to prevention from suppression. I think most of the times we see it on the news, it's after the fact, it's out of control. How can we get ahead of that and actually prevent fires from starting to begin with? Being proactive versus reactive, and really reducing that toxic emission from wildfires. I mentioned this carbon dioxide emission. Well, that contributes to increase in overall temperature, and that temperature results in more wildfires, and it's just this vicious cycle. How do we reduce that? And then product innovation. As you've seen over the last 60 years, we've continued to innovate, make it easier for firefighters. Safety is our number one priority. We are always trying to find ways to offer better equipment, safer equipment, better products, whatever it takes to make their lives easier. That's what we want to do. This industry does not offer second chances, and we want to make sure that it's done right the first time. And part of that is improved testing to avoid unintended consequences. With new chemicals, with new pieces of equipment, they need to be tested extensively. We have 60 years of experience with phosphate chemicals. Those have been tried, they work, they've been proven. We need to make sure that we're testing anything new to that same extent. I really want to thank you all for allowing me to talk to you today about how fire retardants are evolving to meet the challenges of wildfire season. We are really excited to be celebrating 60 years of PhosCheck this year, and I would encourage you all to scan the QR code on the slide that will take you to our virtual museum, where you can learn more about PhosCheck and pick up some really interesting history on wildfires. Thank you again for having me. I look forward to talking to you soon.